Question 3 says that the sum of the digits of a 2-digit number is 9. When we interchange the digits, it is found that the resulting new number is greater than the original number by 27. What is the 2-digit number? This is our question, and the problem statement, when you read it for the first time, it seems kind of complicated, but actually if you go step by step, if you analyze each part of the problem statement carefully, we will see that it is easy to set up an equation in the unknown and then solve it to find the unknown. But what is the unknown? The unknown is the 2-digit number. Specifically, the unknown is the 2 digits of that 2-digit number. So let's start by assuming that one of the digits of that 2-digit number is x. So let's assume, for example, that in the original number, the units digit is x. Now, how can we use this to set up an equation in x? So our number has two place values. There is a units digit or ones digit, and there is a tens digit or tens place value. So, and we have assumed that the number, the units digit of the number is x. So if the units digit is x, what will be the tens digit? Well, because the sum of the two digits is 9, the tens digit must be 9 minus x. For example, if the ones digit or the units digit is 1, then the tens digit will be 8. Now, what will be the numerical value of this number? So you have the digit 9 minus x at the tens place and x at the units place. So the numerical value of this number will be 9 minus x, the tens digit, into 10 plus the units digit. So this will be the numerical value of the original number, and if we want, we can expand this. So 9 minus x times 10 is 90 minus 10x plus x, and this is equal to 90 minus 9x. So the original number is 90 minus 9x. Now the problem statement says when we interchange the digits, so when we interchange the digits, what will the new number be? So the new number will be, it will have x in the tens digit because x will come here, and it will have 9 minus x in the ones digit or units digit, right? So the numerical value of the new number will be the tens digit x times 10 plus the ones digit, which is 9 minus x. So this is equal to 10x plus 9 minus x, and that's 10x minus x is 9x. So we have 9x plus 9. So the key idea behind the solution is that once you have taken the units digit to be some variable x, then you can write the original number in terms of x, and you can write the interchange number also in terms of x. Now we know that the new number is greater than the original number by 27. So let's write this as an equation. So the new number is 9x plus 9. The original number is 90 minus 9x, and to the original number we need to add 27 so that it becomes equal to the new number. So this is how we get an equation in x. And now the remaining part is easy. We have done the hard part of setting up the equation. The remaining part is simply to solve this equation and find the value of x. So let's do that. Let's start by taking this minus 9x and transposing it to the left side. So we will get 9x plus 9, and then from the right side we have this transposed term 9x, and then on the right side we have 90 plus 27. Okay, now we have 9x plus 9x, so that's 18x. So we have 18x plus 9, and on the right side we have 90 plus 27. This is equal to 117. Now we take this plus 9 and we transpose it to the right side so that it becomes minus 9. So we will get 18x is equal to 117, and then we have minus 9, and this is equal to 108. So we basically get 18x is equal to 108, and now we divide both sides of the equation by 18. So we get x is equal to 108 divided by this 18 from the left side. So 108 by 18, that's 6. So we get x is equal to 6. So the units digit of the original number, which was x, that is equal to 6, and hence the tens digit, which was 9 minus x. So the tens digit, which was 9 minus x, this will be equal to 9 minus 6 or 3. So the original number will be 36 or 36. And now you can verify that this answer is correct. If you interchange the digits of this number, you will get 63. And if you calculate the difference between 63 and 36, you will get 27, which is what is given to us in the problem statement. So the answer to this question is that the 2-digit number is 36, and that completes question number 3. Question 5 says that Shobo's mother's present age is 6 times Shobo's present age. Shobo's age 5 years from now will be 1/3 of his mother's present age. What are their present ages? So the unknowns in this problem are the present ages of Shobo and that of his mother. So let's start by assuming that Shobo's present age is, let's take it to be some variable. Let's take it to be x years. So let's assume that Shobo's present age is equal to x years. Now in terms of x, we can also write Shobo's mother's present age, which is 6 times Shobo's present age. So from here we get the mother's present age will be 6 times Shobo's present age. So this will be 6 times 6x years. Alright, now Shobo's age 5 years from now will be 1/3 of his mother's present age. So what will be Shobo's age 5 years from now? Let's write that. So Shobo's age 5 years from now or 5 years later will be the present age x. His present age is x, and then you add 5 years to that. So x plus 5 years. Alright, so what we have here is Shobo's age 5 years from now is x plus 5 years. And Shobo's mother's present age is 6x years, and we are told that Shobo's age 5 years from now is 1/3 of his mother's present age. So x plus 5 must be 1/3 of 6x, and this is how we get an equation in x. So x plus 5 will be 1/3 of 6x, and 1/3 of 6x is basically 6 by 3 is 2. So 1/3 of 6x is 2x. So the equation we get is x plus 5 equal to 2x. And now we just take this x and we transpose it to the right side. And that will give us 5 on the left side, and on the right side we have 2x. And then the transposed term minus x. And therefore we get 2x minus x is equal to x. So we write x on the LHS and 5 on the RHS. So we get x equal to 5. So this means that Shobo's present age is 5 years and his mother's present age is 6 into 5 or 30 years. Now let's see whether this answer is correct. So Shobo's age 5 years from now will be x plus 5 or 10 years. And we see that this age 5 years from now, 10, is 1/3 of the mother's present age, which is 30. And this is what is given to us in the problem statement. So the answer 5 years and 30 years, this is correct. And this completes question number 5. Question 9 says a grandfather is 10 times older than his granddaughter, 10 times older. He is also 54 years older than her. Find their present ages. So we are given the grandfather's age as a multiple 10 of the granddaughter's age. And we're also told that the difference in their ages is 54 years. So we can start by assuming the granddaughter's age to be some variable. So let's assume that we could assume either the grandfather's age or the granddaughter's age. So let's assume that the granddaughter's age is some variable. So let's take this as x years. Now in terms of x, it is easy to write the grandfather's age because we are told that the grandfather is 10 times older than the granddaughter. So the grandfather's age, what will the grandfather's age be in terms of x? Well, it will simply be 10x years because he is 10x older, 10 times older than the granddaughter. Now we are also told that he is 54 years older than the granddaughter. So the difference of their ages, the difference of 10x and x must be equal to 54. So this is how we can form an equation in x. So we must have 10x minus x. This should be equal to 54. And this is actually a very straightforward equation to solve. 10x minus x is equal to 9x. So we have 9x is equal to 54. And now to get rid of this 9 on the LHS, we can divide both sides of the equation by 9. So we will get x is equal to 54 divided by 9 from the LHS, and 54 by 9 is 6. So we will get x is equal to 6. And this will give us the two ages as the granddaughter's age as x years or 6 years, and the grandfather's age as 10x years or 60 years. And let's verify that this answer is correct. So we see that the grandfather's age 60 is 10 times the granddaughter's age, which is 6. And also we see that the difference between the two ages is 54 as told in the problem statement. So this answer is correct. Their present ages are 6 years and 60 years. And this completes question number 9. Question 10 says Aman's age is 3 times his son's age. 10 years ago, he was 5 times his son's age. So today in the present, he is 3 times his son's age, and 10 years ago, he was 5 times his son's age. We have to find their present ages using these pieces of information. So the unknowns are their present ages. So let's assume one of the ages as a certain variable. So let's assume that the son's present age is a certain variable. Let's take the son's present age to be x years. I'm assuming the son's present age as a variable because then in terms of this variable, Aman's present age is easy to write. We are told that Aman's present age is 3 times his son's present age. So from this we get Aman's present age. This will be equal to 3x years. Alright, now we are told that 10 years ago or 10 years earlier, Aman's age was 5 times his son's age. So now what we need to do is we need to write their ages 10 years ago. So let's do that. 10 years ago, what will be the son's age? Well, today the son's age is x years in the present. So 10 years ago, it will be x minus 10 because you'll have to subtract 10. So 10 years ago, son's age will be x minus 10 years. And what about Aman's age 10 years ago? Today in the present, his age is 3x years. So 10 years ago, it will be 3x minus 10. 3x minus 10 years. Okay, great. So we have managed to write the son's age as well as Aman's age 10 years ago in terms of x. And we're also told that 10 years ago, Aman's age was 5 times the son's age. So Aman's age, which is 3x minus 10, was 5 times his son's age, which is x minus 10. And using this piece of information, we can now write an equation in x. So Aman's age 10 years ago, 3x minus 10, was 5 times his son's age, which was x minus 10. So this is how we can form an equation. And now this is easy to solve. We will get 3x minus 10. On the right side, let's expand the product. So we have 5 into x, 5x, and we have 5 into minus 10. So that's minus 50. Now let's take this 5x and transpose it to the left side. So this will give us 3x minus 10 and then minus 5x from the right hand side equal to minus 50 from the original RHS. Now 3x minus 5x is minus 2x. So we have minus 2x and we have minus 10 is equal to minus 50. Now let's combine the constant terms on both sides. So we have minus 10 here on the LHS. Let's transpose it to the RHS, and this will give us minus 2x is equal to minus 50 and plus 10 from the LHS. The transposed term is plus 10. So this gives us minus 2x is equal to minus 40. And now all we need to do is divide both sides of the equation by minus 2, because we need to get rid of this minus 2. Okay, so let's do that. We will get x is equal to minus 40 divided by this term minus 2 from the LHS. So we have minus 40 by minus 2 is 20, and hence we obtain x is equal to 20. So this means that now we can find the present ages. So the sun's present age, which was x years, is 20 years, and Aman's present age, 3x years, is 60 years. And finally, let's quickly check if this answer is correct. If today their ages are 20 and 60 years, then 10 years ago their ages would have been 10 years, 20 minus 10, and 60 minus 10, which is 50 years. So 10 years ago, the son would have been 20 years old and Aman would have been 50 years old. So Aman would have been 5 times as old as his son. And this is what we are told in the problem statement. So the answer is correct, that we obtained. The present ages of the son and Aman are 20 years and 60 years respectively. And this completes question number 10.